Bismillahirrahmanirrahim. Dear students, today the topic for the tutorial is to understand the impulse and step functions here. Okay, let me start with the first question. In the first question, we are given a signal x of n here. Okay, so we know that from n that this is a discrete time signal here. And what we are interested in plotting the g1 of n here. This is our required signal here. How we are going to get g1 of n? We are going to get g1 of n by multiplying x of n with u of 1 minus n here. So first of all, our first step will be just to plot the signal x of n. Then we will plot the signal u of 1 minus n. After that, we are going to multiply the corresponding samples in order to get our desired signal g1 of n here. So let us start plotting x1 of n here. If you remember, I told you earlier that if we are given a discrete time signal in this particular format here, okay, so what we have to do here in this case, we have to look for this arrow sign, or you can say like this is a pointer or a marker here. This will tell us that the particular sample, which is 0 in this case, is at position n equal to 0. Similarly, if we move on the right side, this will be at position n minus 1, but this is a sample value, okay? Similarly, I have another sample value 2 at n equal to 2 and so on. If you move to the left side, it will be the sample value at n equal to minus 1. Similarly, this is a sample value at n equal to minus 2 and so on here. So let us plot our signals here. So our signal now at 0, it is 0 here. At then it will be like 1 here. Then we have 2 here. And then we have 3 here. Okay, this is at 1, 2, and 3 here. And this is your n here. Okay. And similarly on the negative side at minus 1, I have 1 here. At minus 2, I have 2 here. And at minus 3, I have 3 here. 3, okay. 3. At minus 3 here. Okay, so this is our signal x of n here. Let me write it here. This is your signal x of n here. Now, the next step is we need to plot the signal u of 1 minus n here. So, let me plot it on the sides here. We say that whenever our signal is u of 1 minus n, so it means u of n is, we say that whenever I have a signal u of n means this is a unit step signal, okay, and obviously we are talking about discrete time signal, so it means it will be in the discrete time here. Now, so this is u of n is the unit step signal. In the unit step signal, we know that it will start from n equal to 0 and it will go to the positive infinity side here. Okay, on the negative side, we are always going to have 0 here. So it means I have one sample at n equal to 0 here, then n equal to 1, n equal to 2, n equal to 3, and like this one. Okay, so at 1, 2, and 3, the sample amplitude here is 1, 1, 1 here throughout here. Okay, on the negative side, it's all 0 here. So this is your u of n here. So now what exactly we want here, we said that we have 1 minus n here. So whenever we have 1 minus n, here, so it means we are going to have two operations here. The first one is we will perform the shifting, and as well as we are also going to perform the flipping here. I can rewrite this one as minus n plus 1 here. So just to make the thing easier for you, okay, so like this is you can say u, so minus n plus 1, so it means first we can shift to the left by 1, and after that we can flip the signal here. So let us first plot n plus 1 here. What will be n plus 1? N plus 1 means I need to move my unit step signal to the left by 1 here. Okay, so I'm going to get, for example, here, just doing it here. So if I move this one to the left here, so it means the sample at 0 will move to 1 here. The sample at 1 will move to 0. The sample at 3 will, sorry, the sample at 2 will move to 1. The sample at 3 will move to 2, and so on. So basically what happened when I shifted to the left, the sample was shifted to the left by 1 here. So I got u of n plus 1 here. Okay. Similarly, we are done with one step here. So, and we were able to get u of n plus 1. The next step is we need to flip the signal to get a u of minus n plus 1 here. So if I flip my signal here, how it will look like? Simple. Just only we need to multiply the value of n with minus here. So obviously this sample at minus 1 will move to 1 here. Okay, it will move to 1 here. Similarly, the sample at 0 will remain as it is. The sample at 1 will move to minus 1 here. The sample at 2 will move to minus 2 here. The sample at 3 will move to minus 3 here. And so on the left side here. And all the sample values here are 0 here. Okay, so this is your signal u of 1 minus n here. So now what we are basically interested in multiplying this signal with this one here. So I'm going to plot the signal here. I'm going to plot the same signal here. So basically what we have, so at 1 I have 1 here, at 0 I have 1 here, at minus 1 I have 1 here, at minus 2 I have 1 here, at and at minus 3 I have 1 here and 1 here, and it will move on the left side here. Okay, so this is the signal u of 1 minus n here. So now what we need to do, we are interested in finding the multiplication of x of n with u of, we are interested in finding the multiplication of x of n with u of 1 minus n here. So it's quite straightforward here. What we can do here, we can just simply multiply it here. So now the multiplication, we know that. Okay, let me do it with the other pen. Okay, so now what we have, let me take this side. Okay, these two sample value are 3 and 2 here. When we multiply it here, we know that these are 0 0 here. So obviously when we perform the multiplication, I'm going to get the samples 0 multiplied by anything will give me 0 and 0 here. Okay, so it means at 2 and 3 I'm going to have the sample value as 0 here. At 1 the sample value here is 1, so 1 multiply with 1 will give me 1 here. So at 1 I'm going to get 1 here. Similarly, this is 0, so 0 multiplied by anything will give me 0 here. At minus 1, this is 1, so 1 multiplied by 1 will give me 1 again at minus 1. At minus 2, it is 1 multiplied by 2, so 2 multiplied by 1 is 2. So basically at minus 2, I will get 2 here, for example. And at minus 3, it will be 1 multiplied by 3 here, so it means it will be at minus 3 will be equal to 3 at minus 3 here. So this is basically your signal G1 of N here. Okay, thank you.